data would you input? What data would you input? Your x's and y's. So you only have 3 points. So L1 would be 1, 2, negative 1, and L2 would be those. And then you would do a quadratic regression, because that's what you're doing, is writing the equation of the parabola of the quadratic. And it'll give you the same answers that I got, so it would give you that equation right there. Okay? Remember, a huge chunk of your AP exam is no calculator, and a chunk of it is calculator. But there are certain skills you have to be able to do both. We don't know how they're going to show up or where they're going to show up. So you need to be able to solve a system by hand. No bigger than 3, though. No bigger than a quadratic. 3 points. That's as big as it's going to get by hand. I can give you, yesterday we had, remember the airplane problem, where we had a whole bunch of data points? We don't have as many as we want on the calculator. But by hand we'll have 3. So that's that. If you have issues with that, you're going to have to come in and see me. What I want to do now is give you a couple of things. So here is a little extra practice sheet we're going to do. And we need our calculator for at least part of it. I think we need a calculator for the back side, not the front side. The front side is transformation stuff, and the back side is going to be calculator stuff. Uh-oh, who am I missing? Cole? Anybody else missing besides this Cole you want to find out?
Oh, I think we got one already.
Oh, you already did it. Alright, so everybody got one? Alright, so here we go. Number 1, consider the function a of x. It transforms g of x, and I think that says by these are the transformations. So the first thing we're going to do is write our equation for a of x. So g of x is the one I'm given. A of x is my new thing. So how do I get a horizontal dilation? Do I add, subtract, multiply, or divide? Multiply. X or Y? What's horizontal mean? Everybody better be saying X, right? Horizontal is X. Now, if it's by a factor of 2, then that means I have to have a 1/2 X. In other words, instead of timesing by 2, I'm actually dividing by 2, right? I'm doing the opposite. Okay. A vertical dilation by a factor of a 5th, add, subtract, multiply, divide. Dilation, multiply. By what? 1/5. 1/5 is vertical, so doesn't it just stay 1/5? Remember Mr. Passwater's new notes and that awesome sentence he put in there in that box or whatever? If you're doing it to x, it's opposite. If it's in the parentheses, it's opposite. If it's not, it's exactly what it says. So, vertical translation of 3, how do we do that? Plus 3. So there's my equation, for lack of a better word. There it is. The expression for a of x. That's number 1. It says find a rule for a of x. This is called a rule. Equation rule. Okay? Evaluate a of 2. There better not be 1 ounce of confusion in this room. How do we evaluate a of 2? Plug in 2, right? So if I plug in 2, this is actually going to become 1. And then I'm going to look at my table, because my table gives me g's. What's g of 1? 3. So 1/5 times 3 plus 3, which I think I'm just going to be lazy and say is 3 3/5. or 18/5 if you prefer the improper fraction. Okay? Now, we're going to find x. Okay, read it. Find x so that a of x is 12/5. A of x is really just what? Y. So y, the y is 12/5. So 12/5 equals 1/5 g of x. No, excuse me, 1/5 g of 1/2 x plus 3. All right, how do I solve that? Subtract the 3. Oh, yuck. Okay, would that be negative 3/5? Yeah. All right, and then what? Or multiply by 5, whatever floats your boat there. There it comes. And so now we want to stop for a minute and think. This says g of something is negative 3. So we're now g, right? This is the g function, which is in our table. And this says g of something is negative 3. Right? Look at your chart. G of what is negative 3? Negative 3. So this guy right here is negative 3. Would you agree with me? Because the chart says g of negative 3 is negative 3. So whatever 1/2 x is, it has to be negative 3. So it looks like our x value would be negative 6. Everybody good? All right, backside. All right, I copied this problem out of somewhere. Probably should have cited it, but I can't remember now. So anyway, what this is X is your blood alcohol content, and then Y, or C of X, is your relative risk of crashing. So, for example, if you don't have any alcohol in your blood system, then the relative is 1. It's everybody's just 1. But if you have 0.01, you have a 3% more chance of crashing. You understand that? And then 0.03 would be a 6% chance, increased chance of crashing. 0.05, you're up to 38%. Okay, so that's what the chart means. So now we're going to write an exponential regression for this data. So you know how to do this. What is the first thing you're going to do? You're going to enter your data. That's right. Enter your data carefully. I believe this is actual data. I think wherever I got it, it was legit. So if your blood alcohol is 0.09, you have a 3.5 times greater chance of crashing. I don't even know, what is that for the legal limit? What's the
0.08.
0.08, so somewhere in there, probably about 3. We can actually figure that out. So we get all our data in.
I'm good for saying this was just
insane. Maybe for your average. I'm probably
Okay, do you have all your data in? Okay, so now we're gonna do an exponential regression and we're gonna store it. So make sure after you get in there that you give it the y variable to store it when it says store equation, if you have the new calculator. All right, so here we go. I'm going to do an exponential regression. There it is. And as always, the calculator is going to give you the format of your equation. So the format of your exponential equation is y equals a times b to the x. So I got 0.583 times 2.207 to the x. Anybody else get that? Okay, I just always want to make sure, because if you mistype one number, throws everything.
What regression is exponential? Oh, exponential.
It says it in the problem.
Is it Alexa say what play
No, sometimes yesterday we had to figure some out. But one way you can always figure it out is if you do a stat plot, plot your stat, you'll see the shape. So if you know what an exponential looks like, then you'll see it there. If it looks like this, then you know it's quadratic.
I have like one of the old ones, so I'm trying to like select exponential regressions, and it's just like leaving me here. I don't know where to go.
Just hang on a second. I'll use the calculator to help here.
Some technical
Okay.
support.
So we gotta store our equation, right? We've stored our equation. Okay, so now we're ready to, okay, I went through this yesterday. This is when you were having your,
Mitch.
whatever you were having yesterday. So
Well,
seven.
after 6 drinks, 160 pounds.
Yeah.
How much after I live with
All right, now, the next question says, we're gonna, what is our y value if our x is 0.16? Now notice, 0.16 isn't in our table, is it? But we have an equation now that would tell us, right? So if you want to do it by hand, you can put 0.16 right here in this equation and get your answer. But I don't want you to do that. You stored your equation. So get your y variable back. So vars, y, function, enter, and then in parentheses, put the 0.16 because this evaluates, this gives you the y if you put in 1.6. So that's 26.346. So just get your y variable, vars, y, function, enter, and you get this. So that means you're 26 times more likely to, okay, have a crash. All right, what is the residual for 0.11? Now, we have three options. So let's back up and talk about all of our options. To find a residual, we can do it the by hand way. How do we physically calculate a residual? Actual minus predicted. Right? Predicted. Right? So the actual number is in our chart, 6.41. how would I find the predicted value? Alex?
I get 2.207 times 10 to the 10
For what?
for the B value, for like the
Oh.
one that's in parentheses.
Oh, it is times 10 to the 10th, yep, it is, thank you, I was not paying attention. That's probably why I have caution in there to remind myself to pay attention. That is, now, the calculator knows that. So at this point, I haven't caused any damage because I haven't used that formula. But yeah, that's a big number. That's a big number.
But then it makes the other one like I have a different number.
Oh, Y time. I got when I
Yeah,
got
I
Y
got stuff
time
first.
1.6 whatever.
Yeah.
So how do I?
I got something to do with 6
So you have to like redo.
or not
You got
6.
what?
So you go stat.
Exponential.
Did you get your A value to be 0.583?
I think so. Let me check one second.
This was your B value, now that I put that on there.
Yeah.
So if you stored that equation is stored. Let me make sure I stored it. I thought I did, but maybe I'm typing into a different equation. Let me try again. Does 0.16, that doesn't really make sense, so let me tell you, I probably didn't store it. Let me go ahead and store it again. So exponential regression. Nope, there it is.
It could just be
Wait, Alex. Alex, am I not able to do that?
Alright, now I got it. Okay.
Yeah, we have the same thing.
Oh, we do?
Yeah,
Oh, okay.
that's what I was asking. What?
What does it say?
Way clearer than more. I have something to the times 10 to the negative 16. Or times 10 to the 16. Yeah,
Okay, that does not even make sense. I mean, look at that, that would be, look at your table of values. I mean, 0.15 is 22.
yeah. That's what got my.
How did you get this wrong?
Pit bulls.
I haven't gone back and checked your data points, I'm sure they're all in there, right?
O-line. What was the one from last year? I remember being funny.
But he has the same
This is,
answer as
well,
I
it
do.
was yellow. It was bright yellow hoodie with a green pit bull.
I remember
Yeah,
Voss
but it's
wearing
not
that to
very
Spanish. Dude,
That
that
doesn't make sense.
I personally
For
wet
times
suit
10 to the
is the
16.
toughest.
That's
Is it still wet suit for you?
Yeah.
Okay, I just retyped it. I don't know what you did, but I just retyped it.
Oh, it's 0.16, not 1.16.
Be like wet suit.
Yeah.
Oh, it's 0.16?
It's
On there, it's
1.6 probably.
Oh,
Freshman year.
0.16.
I'm trying to think of who the dude was
Yeah, because let's stop and think about it for a second. What are those X values? Oh, what are your X values?
Oh, 20.
Would you even be alive if it was 1.6?
No, I think the max is 0.5. I took
So, thank you. So, yeah, so it works out. So, did everybody get this number?
Yeah, it's the receipt.
Okay. So, now we're gonna do a residual. So we can use this equation, and X is 0.11, so we can put 0.11 in there, calculate that out, and that would be our predicted value. Or more easily, we can just do Y of 0.11, 0.11, and I got 8.008. Do you match that one?
Yes.
Yeah.
Okay. So subtracting those would give me a residual of negative 1.598. Now this is if I'm doing it by hand, okay? I would never do that if I'm sitting here with my calculator, but that's how I could do it by hand. What does a negative residual mean?
The model overestimated.
The model overestimated. The model gave me something higher than the actual was. Okay? Now, go back to stat. Let's edit. And click over to your residual column. And what did we want? 1.11?
All my comments.
Seventh one down. And if you go down to the seventh number in the chart, look what it says. Imagine that. So that would be the easier way to do it. What else could we do? We could graph it. So let's practice that. How do we, if we decide that we want to get our residual from the plot, do you remember how to do that? What do we do? We gotta get the plot first. So we're gonna have to go to stat plot and change Y2 to residual. And then, I don't know what you've been doing, but probably you're not gonna see anything. So remember zoom 9, zoom stat. We'll fix it for you. And do you have, I'm not gonna put the points up here, but do you have a residual plot that looks kind of like, if I connected them, it would look kind of like that? And we want the one for 0.11. So if you hit trace and just keep arrowing, you will find the residual for 0.11 is negative 1.598057. So actually, if you need more accuracy, your plot probably gives you the best accuracy. All right? Well, let's answer E. What does part C mean? Well, we already answered that. What does that residual mean? The overestimate. The model overestimates. What percentage of variation can be explained by the model? Shoot, I should have answered that question already. But now I have to go back and do my exponential regression again. What percent of the data is explained by the model? 97.122. R squared. R squared. All right, got one more sheet for you now. A little bit more practice with our calculator. Believe it or not, you guys have pretty at unit 1. One down, one
I thought the same thing.
We have a test on Monday. We know we can't have a test on Monday. Test on Tuesday.
Why can't we,
Homework on Monday. Homework due Monday.
Why do we even go to school? Like, why can't we just be like, I want to be a plumber, and then go to school for being a plumber?
Can't we just wander around and be like, nah, I'm hungry. We need to just leave.
Exactly. Why?
Actually,
Why do we
not
have
now,
to
because I want you to be up with us
Oh,
here.
okay.
All right, everybody's got,
Dude, if you think about it, no matter where you go on the earth, you have to keep on paying taxes. Like,
It's not true. No. There's certain countries. There's,
oh.
but there's
yeah,
one
okay,
country. No, there's countries that are like really stupid, like
All right,
Morocco.
let's work on this first one together.
Monaco.
All right, we got a kicker for the Baltimore Ravens. Great kicker. Recent kickoff, the height of the ball, measured for selected times, this data shown in the table above. Based on the situation and the data, do you think this would be linear, quadratic, or cubic?
quadratic.
You guys, exactly, Cole. Cole went like this. If you kick a ball, isn't that what it's gonna do? So that would be quadratic. I said a minute ago, or maybe it was in the other class, I can't remember, that often, if you have a word problem, the problem itself will give you a clue. And in this case, it certainly does. We're kicking a ball. So you're going to input that data and do a quadratic regression, and you're going to store it. And then you're going to use the calculator to evaluate at 1.3. Okay? Where's your calculator?
It's charging currently.
It's weird.
I got it back today and it was,
Well-
he had it dead. I apologize.
Turn it off and then back on, and maybe it has some juice. I don't know.
It's off right
You better pray it does, or you're getting
now. A
infected
little
again.
bit. It'll work. Oh, we got some back. We're good.
Good.
There'd be enough to last you to the end of class.
It
Okay,
sure
are you
will.
done?
Lock in, bitch. Minus.
Oh, those are the old ones.
Yeah.
I'm not doing this, so I'm counting on you people. Write your equation, ax squared plus bx plus c. Is that in?
Yeah, I got them all.
Alright,
I don't know why I'm blanking on one.
so now we gotta go to stat, edit, or calc, I mean, yeah. Quadratic, L1, comma, L2.
Where was it? I saw you do it.
Buddy.
There you go, the commas. Comma, L2, comma, vars, y, equal, or enter, 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 and there it is.
Awesome.
All right, so I have no idea. Cole got negative 4.915 x squared, does that sound right? Plus 13.714 x plus basically 0.07. Okay, that's our equation. Now, if you stored it like I told you to, type in your y again, so vars, y, function, whatever, I may have that in the wrong order, whatever. And give it a 1.3.
Wait, why are my wait, let me double check. Why are my points
Round up a little bit,
mine are like barely off?
Go back to stat.
A, B, C.
okay, well, if you got a number typed in wrong, then probably one number's typed in wrong. We should never be off,
Okay.
so we should all be exactly right on. Okay,
I learned so quick, I taught you how to do it too.
okay, so would you get 9.592?
I don't know if I do this info, but I have the info.
Did you plug in? Plug in A. I don't know if this is too. Use my contacts.
We won't let you calculate. Well, I don't know, I'll keep at it, I don't know what's going on. Okay. All right, so we got number one done. Number one's done. All right, let's go on to number two. All right, the price of Amazon stock fluctuates over time. On certain days, we're this. Okay. All right, so T is the number of months after December 6th, and Y is the value of the stock. Okay. Based on the data in the table, what do you think would be the best model to use?
Quadratic.
Why do you think quadratic?
It goes up and it goes back down.
Goes up and back down, right? I think you're right. couple of different ways we're gonna be able to tell. First of all, if you wanted to take the time to plot your data, do a stat plot, it should have a parabola shape. Or, when we look at our residuals, they shouldn't be huge numbers, right? So let's go ahead and assume it's quadratic and see what happens. Go ahead and put your data in. Back here, look at hers real quick. Put your data in and
What's your?
Data?
you got an so that was fine.
26.
Why was 1.3 and 1.5?
Because that's like near the peak of the football size, like
Oh,
right here.
yeah.
Maybe I was 1.9.
Hopefully correctly.
I would help you out.
I would have guessed
You said quadratic.
Or it's just stat, place, or.
Start.
Is it quadratic? We've got a quadratic.
You do not have L1.
Are you cubic or quadratic?
Would it be about?
You had wrong.
I have not decided yet.
but that is.
Why do you, just curious. Color's good.
Right.
If we,
And that's just back down.
I don't know, we shall see, put it that way.
What did we get
I'll hit you.
this
Always
time?
down for the ride.
I'll hit you up. Okay.
Why was I geeky?
It wouldn't be a bad spot to draw. Country roads would not be a bad spot.
Yeah.
We got, who will share your equation so that we can all match it, hopefully?
If I'm getting
269 x squared.
X squared plus 9.162 x plus 99.972.
All right, how does that look to everybody else?
That's what I got.
Perfect, everybody got that, good. So that is B. C. Now we're gonna use our equation and we're gonna put in 16. What do you get when you do that? 137. 177. Point, give me 3 decimal places. 790, okay.
This is just another.
Everybody okay with that?
Plug in.
The actual price for one share of Amazon stock was 168.61. So, that number's not in the table, but he's telling me, or he's telling us, that the actual value was 168.61. Well, can we find the residual really easily since he gave us that number already? The actual was 168.61. The predicted was 177.790. So whatever that is, that's your residual. So it's a negative something or other. And what does that mean? The model overestimated again for that number. Everybody okay with that?
Sure.
All right, let's turn it over. This one we're going to do a cubic regression for. I don't think we've done one yet, but press the same buttons. So let's work on number 3, you and your partner, and then we'll gather together and see if we all got the same answers.
I can do it. Chop chop, table boy. Relax over here. How?
Yeah, they told us it's cubic. Let's do all, see if you can answer all the parts. Wow, look at that r squared value, that's pretty good.
Sorry. That does have numbers. See. Something else.
You're going to-
I think. Just over that's like the percentage of how accurate it is. So I would say, it's accurate, because I'd say
All right. Did your equation start with a 0.294 x cubed?
Yes.
Okay, so I think this is good there. What did you get when you let the calculator find the x, or find the y value when x was 8? 52.357. So then you get question C. The highest rate in U.S. history was 20%. Okay? Based on this information and the answer you got, do you think this regression model is useful in predicting rates into the future? No. No. 52, I heard somebody over here say 52 is just totally out of line, right, with what history has been. So the model works great. We didn't talk about it, we should have. The model works great for the data that's given. But as soon as you start expanding too far out, then it gets a little out of whack. That happened with the blood alcohol content one. We didn't talk about it, but if you were to put in, think about what an exponential looks like. An exponential curve looks like this, right? So here we go, here are our data points. Well, if you went out, if you typed in, I don't know, you couldn't, according to somebody saying you would be dead. But if you typed in a like 0.3, it would give you some astronomical number that doesn't even make sense in the context of the problem. So you have to be careful sometimes, your models aren't perfect. And they're designed for the data points. They're designed for the data points. All right, 2 more and we'll be done for the day. Number 4. Getting good practice on our calculators.
I'm pretty sure. I'm pretty sure in high school, like high school.
Bro.
You wait with. Need your help. How do you find an 8?
Boy, you tweaking.
Okay, so we're doing another cubic regression. We're putting it in.
I'm gonna try to figure it out real quick.
We got it already.
Oh, like,
Go ahead and do those parts of the question again. Make sure you know how to do this.
Y of 13.
yeah.
Which part?
Or like Y of 8.
There has to be some efficient way.
See, this is what happens when you know how to calculate. Yeah. So you go to bar. It's yes, it's your fault. Okay.
I won't get it out.
So I went to bars. Y bars. Parentheses, type in whatever number you want.
Are we using cubic on this one?
Did you read the question? Question A.
Oh.
Thank you.
She wasn't here the day that we did like the diagnostic. Wait, I used
Chill, yo, I figured it out.
No, dude, that's not what I want to do. That's just like moving. And you feel
I am very unconfident.
no, dude, it's the right answer.
I needed that pick.
I don't have like
But you feel like you're probably right now. Even though that's probably inaccurate. Just playing with your confidence.
I don't know how to do it. What incarnation?
Correct.
so close to work. I know it's very close to work.
All right, you got number 4 done? This is gonna be, I'm using
Pretty much.
this paper, here we go. For your, is that
No,
point?
yeah.
Okay.
0.001.
So for his first term, he got .0015, is that what you got? X cubed? And then I'm down 1. For his Y value in 1967, he got 20.475. Perfect. All right, one more. This one has a couple extra parts to it, so you can bring out more.
That is so
Did you say
Clearly it's not.
Now, it tells you to use a linear regression in part B, but in part A,
He got what you got.
did you look at it? In part A, based on the data, why does it seem linear might be appropriate? All your Y's are moving in the same direction, right? Right, as X goes up, Y goes up, or right, you know, that kind of relationship. With no up and downness to it. I'm sure you already have it done.
Thanks.
Thanks, all right, we're gonna use you as the model then.
Oh, God.
Okay, so
Sir Callan?
I'm using this for Brian's paper, and we're gonna talk about his first answer first of all. Based on the data presented in the table, explain why a linear regression model is appropriate. He wrote yes.
I forgot to explain it. I looked for it. It normally says explain it.
So, we need to explain that, we already did, we talked about that, so he'll fix that. Remember, Kellen, that when you write an equation, it's gonna be y
Equals
equals.
Y, yeah.
Yeah, so don't just put the whole equation, alright. Anybody have any, but he got 1.078x plus 23.086. That sound right? And then, for the next one, he had to do t equals 33. He got 58.673.
Yeah. Yeah.
For part C.
What is that?
58.673. Are we in agreement with that or not?
Yeah, we're good with that.
I got 58.
58.673.
I got 59.026.
In your face. 0 sucks.
Yeah, I got the same thing.
I don't know why I said anything. To be gay.
Alright, everyone needs.
Oh, yeah, so it's you.
As well.
Yeah, we have to read myself had like one book had all the books. So that's why I got her name.
All right.
Bars, function,
No, it's 23.
In 2021, which was T equals 33 year, the women accounted for 55% of all primary care doctors in the UK. What is that? 55 is what? The actual value. If he's right, the predicted value was 58.673. So your residual was negative 3.673? Is that okay? All right. One more quick check to make sure you're on target here. Let's use the data you have right now in your calculator. All right, I'll give you a minute to wrap up problem 5 or whatever what that was.
ask her. David's got a question.
I think mine's doing the same thing.
What?
Whenever I plug my number, like I know how to plug it in now, whenever I plug it in, it's not giving me the same answer as other people.
Well, then your equation's not right.
If you plug in
And then you try to
The
diagnose
equation
off
looks
of
the same.
because it's 21 years after.
We have the same.
What was this linear?
Yeah, it was number 5.
Oh, no, it's 50.
I plugged in 32. You keep plugging.
No way.
It's the same equation.
Are you like not putting the prices?
I tried not.
I live in Redmond here.
Are you over here?
You still have your equation. What was your equation?
55%.
Okay, your equation's wrong. Your equation's wrong, so your data must be wrong. You got a mistake.
Yeah, I live right by Big
Gary. My name is
Who still has the equation for the
I always
last
went there.
problem?
Really?
freshman year. It was either Garen,
Astro minus predicted.
Cathedral, or Noble.
You what numbers is it?
Or we went to Nobles and Westport School together. Wait, you know JJ? One of the managers?
Yeah.
Jeremiah? Yeah. He went to West as well in 6th grade.
Really?
Yeah. But I went to
I know
Nobles
what
at
it was.
East and 6th
You
grade.
didn't store your equation. So it was plugging in X out of
East and
You
West.
have to store.
Harmless. Creekside.
Okay, some of you packed up, and that's a shame. When you back up early, I take that many minutes off your next test.
Oh, no way.
Yeah.
Unpack right now.
I'm unpacking. I'm unpacking.
All right, what I want you to do now is, I want you to go back for this last set of data we put in, a linear equation. Oh, I didn't do it. I didn't do that. So go back to your linear equation. If you've lost it, go ahead. The data's still in there, right? Yeah. So that's no problem. The data's still in there. I want you to go to edit, and go over to your residuals. Remember how we do that? L6, L7, wherever you're at in your residual column. And tell me what the fourth one down is. What's the residual for the fourth data point? Negative 105? Does that sound right?
Yeah.
All right, now I want you to graph your residual plot. So we're going to go to stat plot. Stat plot. And I don't know if you, L1 should be X's, but L2 should be residuals, right? L1 and residuals. And then go ahead and graph it. And I can't remember how many data points we had, but however many points we had.
7.
7. We have 7 dots.
So we have residuals.
Some of them above the line and some of them below the line.
Go with the first one, click enter, like the first one.
Yeah, you got 7
Make sure
dots.
it's on. You should have like.
Click over to the fourth one. Is it the same one, same number you did before?
Just a more defined version, like a longer.
Yes, yes. So, he's pointed out something we observed earlier. If you use your plot to get your residual, it's a little more accurate. A few more decimal places. Okay, that's it then. All right. So, the way I see it Excuse me, I'm gonna turn this off. Tomorrow, or no,